Good afternoon. My name is Good afternoon. My name is Luis Suarez, and today I'm going to talk about temperature and rate of reaction and how it affects the rate of reaction. So, what does the rate of reaction means? The rate of reaction is a measure of how quickly a reactant is used up or a product is formed. Is the speed of different chemical reactions varies hugely. Some reactions are very fast and others are very slow. The speed of reaction is called the rate of the reaction. So, a reaction takes place when two particles collide with a certain amount of energy. The minimum amount of energy needed for a particle to react is called the activation energy, and it is very different for each reaction. If particles collide with less energy than the activation energy, they will not react, and the particles will just bounce off each other. So, what factors affect the rate of reaction? So, factors that influence the reaction rates of chemical reactions include the concentration of reactants, the temperature, the physical state of reactants, their dispersion, and if there's a presence of a catalyst. On the right side, I don't know if you can see very well, let me move this up. You can see the fractal molecules and the kinetic energy and how lower temperature and higher temperature affects it. So the effect of temperature on a reaction. The higher the temperature, the faster the rate of the reaction. In many reactions, a rise in temperature of 10 degrees Celsius causes the rate of reaction to approximately double. At a higher temperature, particles have more energy. This means they move faster and are more likely to collide with one another. On the right side, you can see two chemiluminescent light sticks that shows how temperature affects the light emitted by the light sticks. So, at higher temperature, the light will glow brighter in hot water than in ice water because it produces more photons of light per unit time. So here you can see how the character on the left side, it represents a low temperature, which in this case is because it's a night and there's not enough amount of kinetic energy. That's why he's asleep and he's just not doing anything. So therefore, he's very unlikely to react. Instead, the right side, you can see it represents a higher temperature, which is during the day, and you can see how everything is moving, everything is like bouncing. You see a cat on the ground, the dog on the right side, and he's just doing a lot of things at the same time, which is which means there's a large amount of kinetic energy, and therefore he's more likely to react. This is an example that I wanted to tell you guys about. So this is why a battery is more likely to run down more quickly in cold weather. So at low temperatures, the reaction that generates the electric current proceeds more slowly than at higher temperatures. So if a battery is not in use, it will discharge more slowly at low temperatures than at higher temperatures. However, if a battery needs to be used at low temperatures, then warming it up speeds up the reaction that generates electric current, giving it giving you more power. So this more. Let me put this up here. So any reaction with a favor of free energy charge do not occur at room temperature. To get such a reaction started, energy must be added to increase the frequency and the force of the collisions. Once started, the reaction sustains itself as the energy released by reacting molecules give other molecules enough energy to react. On the right side, put a freezer, which you probably don't know what it is about, but so refrigeration retards the rate of growth of bacteria in foods by decreasing the reaction rates of biochemical reactions that enables bacteria to reproduce. This is my works cited, and thank you for watching.